This is something I started doing a few years back. I simply took some cardstock, and I got this cardstock from a printer who had some leftover remnants from a job they did. These are a little thicker. I then printed up the base formulas and each of the variables that you would need for each of these formulas. I make one of each of these sets for each of my students. Let's work with the ideal gas law. And what I found is that a lot of students have trouble identifying how to get a variable isolated. So in this case, I have pressure times volume equals N, which is the number of moles, times R, which is the gas law constant, and temperature. And what we need to do is we need to isolate each variable. So what I ask the students to do is solve for each of the variables. If I wanted to solve for moles, for instance, I'm multiplying by R, so I'm going to divide by R on the other side. I'm multiplying by T, so I'm going to divide by T on the other side. So to solve for the moles, N, that's P times V divided by R divided by T. And then if I wanted to solve for, say, the volume, I simply know that pressure times volume equals nRT. So if I divide by the pressure, I get the volume equals nRT divided by P. In each of these cases, students can actually visualize as they manipulate each of the variables and see how each of the variables can be solved for. We can take the combined gas law. Combined gas law being initial pressure times initial volume divided by the initial temperature is equal to the final pressure times the final volume times the final temperature. And again, here we can manipulate. If I wanted to solve for the initial pressure, I can move the temperature up to the other side and get PVT over T times V, and that will give me my initial pressure. So pressure equals PVT over TV. I can then return the formula back to its original, and if I would like to solve for the final volume, again I would manipulate the variables, moving the T over, moving the P over, and what I end up with is V2 equals T2 times P1 times V1 divided by P2 times T1, and this gives me my final volume. So these cards become helpful to help students identify the variables involved in an equation, how to set up each of the equations, and then how to manipulate those variables to solve for each of the individual variables. I use this in chemistry. I also use this in physics.